Hello, we're continuing our discussion about aqueous solutions, and let's start talking about some reactions in aqueous solutions. So let's take a couple of compounds. Let's take calcium chloride and sodium carbonate. And they're both solids at room temperature and pressure. But we can dissolve them in water. They dissolve and they dissociate. And so instead of saying that they're solid, we can say that they're aqueous, that they're aqueous. And we write that a substance is aqueous, it means it's in water. If it's ionic, it also means that besides being dissolved, it dissociates into ions. And so we'll have calcium ion plus 2 chloride ions plus 2 sodium ions plus a carbonate ion. And so let's see what might happen if these were to react. So I've got some sodium carbonate and some calcium chloride that I've already dissolved in water. They're white solids to begin with. And so here's a cup that's got some calcium carbonate in it. Here's a cup that's got some sodium carbonate in it, rather, excuse me, and a cup that's got some calcium chloride in it. So let's add these together. And did you see what happened? We've made this white solution. A reaction's taking place. We want to figure out what is taking place, what has made that reaction. And so what we're going to do is we want to see how these might react. And so what does a positive ion want to react with? A negative ion. So we're going to take the positive ion from one of our compounds and see how it might react with a negative ion from the other. And so calcium carbonate plus sodium chloride. And one of those made that cloudy white precipitant that we made in the cup. So which one is it? Well, from your experience of just living life, you know that sodium chloride dissolves in water. So it's going to remain dissociated. Whereas the white solid that we made is going to be the sodium carbonate. And so this is our precipitant that we oftentimes abbreviate as PPT for precipitate. And so we can write several equations that describe this phenomenon. We can write what's known as the molecular equation that shows everything as if they were molecules. And so we got the calcium chloride, AQ, plus the sodium carbonate, that's AQ, reacting to make calcium carbonate, that's a solid, plus sodium chloride, that's dissociated. And we'll need a 2 in front of there to balance that. And so that's a molecular equation that shows all species as being part of some sort of quote-unquote molecule. Even though these are ionic species, we're going to treat them as pseudomolecular in this example. Then we can write the ionic equation. When we write the ionic equation, everything in the molecular equation that was a Q, we now write as ions. So calcium 2 plus 2Cl minus, plus 2Na plus CO3 2 minus carbonate react to make calcium carbonate that's a solid. Since a solid means it has not dissociated, and 2Na plus and 2Cl minus. Everything that's AQ is written as an ion. And for simplicity's sake, after all these ions, we could be writing AQ because they are in water. But just to keep these a little bit clearer, and just so it all fits on my page, I'm leaving the AQ off of each of those ions. It's just sort of understood. So the molecular equation shows everything as if they were quote-unquote molecules. The ionic equation shows everything that, from the molecular equation, that was aqueous being present as an ion. Solids remain solids. And then we can write something that's called the net ionic equation. And the net ionic equation is only going to show those things that change chemical form from one side to the other. And so if we look, I've got 2 chloride on the left on the reactant side. I've got 2 chloride ions on the right-hand side. They cancel out. 2 sodium ions on the reactant side, 2 sodium ions on the product side. They cancel out. And so my net ionic equation is only going to show those things that actually change chemical form from the net ionic equation as you go from the reactants to the product side. So it's going to be calcium 2 plus plus CO3 2 minus makes CaCO3 as a solid. And that's my net ionic equation. What about the sodium ion and the chloride ion? They're just floating around in the beaker, in the cup. The white particles that you see are calcium carbonate, and they would eventually settle down the bottom. They would precipitate out. But those chloride ions and sodium ions are still just floating around in there. And so they're just watching what's going on. So they're called spectator ions. And so we're looking at precipitation reactions. There's a host of rules that you need to be aware of that are ways of predicting whether or not certain species will precipitate or not. And so one of those set of guidelines in terms of solubility is that all sodium compounds, and actually it's all 1A compounds, all those that are in column 1A on the periodic table. So that's not just sodium, but sodium, lithium, potassium, and so forth. Those salts are always soluble. Anything that contains the ammonium ion is going to be soluble. And anything that has the nitrate ion in it is always going to be soluble. And there are others, and we'll talk about some of those other rules a little bit later, but the one that comes to play in this reaction, of course, is the sodium ion. And then there's some rules about things that are insoluble. And so carbonate salts are insoluble, except when there was one of these things that are always soluble. And so sodium carbonate, that sodium is going to make it become soluble. In this example that we saw, we now had calcium ion that's present. And so that calcium is reacting with the carbonate to make a salt that's insoluble. And so we've got a beaker. It's got water in it. And so we got sodium, and we had carbonate that we put in there. And then we added calcium and chloride. And so these ions are roaming about, and they're hydrated. That's how they were able to dissolve to begin with. But it's something about that calcium and something about that carbonate that they're really strongly attracted to one another. And so what happens is they come together and they precipitate out to make a solid. And the sodium ions and the chloride ions, they're just hanging around, and so they're the spectator ions. So that's an example of a precipitation reaction. Thanks for watching.